Hi, it's Emma and I'm back with another video for Chemistry GCSE, WJEC really, but AQA and Edexcel can use them too. Today we are going to look at giant covalent structures. So when a covalent bond happens, it can make either a giant covalent structure or a small one, which we call a simple molecule. So I've spoken about the simple molecules like O2, H2O, CH4 in the last video. You have to know the structures. I think there's 5 giant covalent structures and they're all made from carbon. So if you were to go on the periodic table, you would find, sorry, I've got a bit of a trapped nerve in my back. You will find carbon in group 4. Because it's in group 4, it means it has 4 electrons in its outer shell. And that means if it's in group 4, it's got 4 electrons in its outer shell. It can do up to another 4 bonds. It can share or do something with the other 4 spaces that are in its outer shell. And it's quite important that you remember that if you're higher really, because the different structures, they do like you to know how many bonds each one's got. So the first one I'm going to show you is diamond. That obviously doesn't look like a diamond to you and I, but each black circle there represents a carbon. And if you look at the picture, so let's go for this one, because obviously these structures are massive. There will be millions and billions of these carbon atoms stuck together, but that's the picture they want you to recognise. And if you look at one in the middle, so let's say this one here, I hope I'm pointing to it. There are 4 lines coming from that middle carbon. That is showing me that there are 4 bonds. So diamond, we all know what diamond is. It's a very hard structure. It's made of carbon, and each carbon atom is bonded to 4 other atoms. So there's no free electrons or anything like that. So diamond does not conduct electricity. Because diamond is very hard, it's used in things like drill bits. We also know that it's used in jewellery because it's nice to look at. So that is one structure. Diamond, recognise that diagram as diamond. Each carbon is bonded to 4 other carbons. Next one, I will go for this one here. I've seen this picture look slightly different every time, but you should be able to recognise it. This is graphite. So again, each dot on my diagram represents 1 atom of carbon. And if you look at one in the middle, each carbon is bonded to 3 other carbons. Now, I told you that carbon was in group 4, therefore could potentially have 4 bonds. Graphite only has 3, which means there is a free moving electron, and that makes graphite able to conduct electricity. If you remember with metals, a free moving electron means electricity can flow through it. So you just need to know that graphite looks like this. It's layered. So the bonds in graphite are very strong, but the bonds between the layers are not. They're quite weak, and this makes graphite quite slippery. And for that reason, it's used in things like lubricants, you know, if you're oiling up machinery and things like that. It's also used in pencils now. We don't have lead pencils. The middle bit of our pencil is made of graphite. And because it's slippery, the pigment moves from the pencil to the paper when you're drawing. So graphite, it's layered. Each carbon is bonded to 3 different carbons, and there is a free moving electron, which means it can conduct electricity. Next one. This is graphene. So I might edit this if I can to get the names up, because I've not written it out. So I'm going to just draw the word graphene. This is graphene. That's how we spell it. That's graphene. Graphene is one single layer of graphite. So you don't have the layers. Again, each carbon atom is bonded to 3 other carbon atoms, which means it's got a free moving electron. Therefore, graphene also conducts electricity. So all these things I'm showing you, they only contain carbon. But the thing is how the carbons are bonded to each other. That's what makes them different. Graphene, scientists think of graphene as it's really, really strong and really, really light. So it has a high tensile strength. That is a posh way of saying it's strong. And it also has a low density, which is a posh way of saying it's light. So we haven't really tapped into the potential of this material yet. But if we could, this stuff is stronger than steel and weighs hardly anything. So if we could make bridges and things out of it on rockets, then we would be saving fuel, we would be saving energy. So there's so much potential in this material. Next one are fullerenes, okay? They are like spheres and cages, tube looking things. So here are examples of fullerenes. Hopefully you can see them. The way you can identify a giant structure as opposed to a simple molecule is there's no formula for it. There's just millions of them bonded together. However, if you're doing higher, they want you to know about one type of fullerene. It's a cage-like one, so it looks like a ball, like this. And it's called Buckminster, which I bet I don't spell it correctly. Buckminster. Oh, I can't even. Fullerene. Fullerene. I hope this is spelled correctly. Hopefully my spelling, my writing is that bad that you can't even see the spelling. And they just want you to know really that that's an example of a fullerene. Looks like this, and it's got a formula of C60, and that's because it's in a cage-like shape. But generally, the giant structures don't have a formula other than this one. So these type of fullerenes are actually used in drug delivery in the body. So let's say a cancer patient or someone, I don't know loads about it, but a patient needs a drug getting to a certain part of their body. Well, the drug will be put inside the fullerene, and then it will get to the part of the body it needs to without damaging other areas. Nanotubes, they're basically like graphene rolled into a tube. A lot of potential with these as well. High tensile strength, low density. Just get used to it. If you see high tensile strength, it means strong. Low density means light. So they are the 5 different types of giant covalent structures that you need to know about. In WJEC, I've seen questions where it's literally like a page of writing and you've just got to pull information out. Or they want you to identify this is diamond, this is graphite. That's more of a, maybe a foundation question. This is graphene. But once you get your head around it, I think you could definitely get the marks on that. So diamond does not conduct electricity. Graphite and graphene and the nanotubes do. And we don't really speak about conducting electricity in this because it's sort of in its own shape. And that's everything for today. Hopefully the video makes sense. Hopefully I've spelt this correctly, buckminsterfullerene. They're not too strict on spelling in a science exam other than the 6-marker question. So if the examiner can see that you're trying to say buckminsterfullerene, then you'll get the mark, if that's one of the points to get a mark on. But it's got a formula of C60. Thank you for watching. I'll see you again next time.